morning everyone. Welcome to today's class, that is lesson number 9 of first module. Okay, in the previous class, we covered the topics that were covered in previous class was field identification of soils. Okay, in today's class, we'll be solving numerical problems based on compaction test. Okay, good morning everyone. Can you all hear me? Okay, today we'll be solving problems, numerical problems. I hope you all are ready with book pen. Also, you need a graph sheet. If you don't have a graph sheet, you can. If you have a scale, that's okay. You can draw a simple graph in your book using a scale. If you have a graph sheet, then very good. If not, please be ready with a scale. Okay, write down the first problem. Please write down the first problem. I hope all of you can see the question on the screen. All of you have copied the question. Okay, all of you have copied the question. Okay, I'll start with the solution. Okay, the following data has been obtained as standard laboratory compaction test. Okay, for each water content, the weight of the container or the weight of the mold plus compacted soil is given, and there are six trials are conducted. First trial, second, third, fourth, fifth, and sixth. You can see the weight is increasing up to certain point, and after that the weight is decreasing. Next, the specific gravity of soil particles is 2.77. The container is 944 cc, cubic centimeter in volume, and its weight is 1.978 kg. Full stop. Plot the compaction curve, determine optimum moisture content and maximum dry density. Also compute voids ratio and degree of saturation for optimum condition. Now uh, you have to draw a table. Okay, can you see this? Very important type of problem in almost all the question papers. These kind of this type of problems, they have appeared for at least 10 to 12 months. So copy the question. Okay, uh, the water content for the first trial is 5.02. Please draw the table. For the second trial, it is 8.81. For the third trial, it is 11.25. For the fourth trial, it is 13.05. Fifth, 14.40. And for the last trial, it is 19.25. Please write this down. Okay, next, weight of the mold. It is designated as W1. It is given in the question, weight of the mold or weight of the container. Okay, weight of the container is 1.978 kg. So 1978 grams. 1978 grams. Okay, write the value in grams, and for all the trials, the value will be same. We are using the same container. So weight of the malt for all the trials will be 1978, 1978, 1978 and 1978. Okay, have you drawn the table? And okay, have you completed this part? Yes or no? Anyone? Have you completed? If you have completed, please raise your hand so that I can move to next step. Okay, next step, weight of the malt plus soil. It is also given in the question. For each trial, the weight of the malt plus soil is given. So write it down in terms of grams. For the first trial, it is 3,580 grams. Second trial, 3,730 grams. Third trial, 3,932 grams. Fourth trial, it is 4 kg, meaning 4,000 grams. Fifth trial, it is 4.007, that is 4,007 grams. And for the last trial, it is 3,907 grams. So water content and the weight of malt plus soil, it is given in the question. Instead of container, I am using the term malt because that is the correct term. Container is a very general term. We are using a compaction malt here, so I'm using the term malt. Okay, next I have to calculate weight of soil. Okay, now weight of soil is given by weight of malt plus soil minus weight of malt. Weight of malt plus soil, weight of minus weight of malt. So W2 minus W1. So for all the trials, you have to do W2 minus W1. Okay, for the first trial, W2 is 3580 minus W1 is 1978. For the second trial, 3730 minus 1978. 3932 minus 1978. 4000 minus 1978. 4007 minus 1978. 3907 minus 1970. So please tell me what are the values. For the first trial, what is the weight of soil? Anyone? Simple calculation. What is the weight of soil?
1602.
How much?
1602.
For the first trial, 1602 grams. Okay. Next trial,
1752 grams.
17.
52.
52 grams. 1752.
Okay. Next trial, third trial,
1954.
1954.
1954. Fourth trial,
2022.
2022. Fifth trial,
2029.
2029. Last trial,
1929.
how much?
1929.
1929. I hope all of you are getting same answers. Anyone getting any other answers? All of you are getting same answers, right? Okay, so we'll move to next step. That is, we'll calculate bulk density of soil. To calculate density, density is given by weight of the soil divided by volume of the mound. So weight of the soil we have calculated here. We have to calculate, okay, volume of the mold is given in the question. If you refer the question, the container is 944 cc in volume. So the weight of the container is 944 cubic centimeter, and it is same for all the trials. We are using the same mold. Okay, so volume is 944. So for the first trial, bulk density is equal to weight of the soil is 1602, volume is 944. So what is the density? Weight of the soil is 1602, volume of the mold is 944. So please tell me what is the density, bulk density of the soil.
1697.
One,
0.697.
1.68,
697.
1.697.
1.697. And the unit of the bulk density will be, weight is in terms of grams, okay, volume is in terms of cc, so bulk density is gram per
Per centimeter.
cc or centimeter cube. So calculate the bulk density for second trial. Weight is 1752, volume is again 944, so bulk density will be
1.8559.
1.8559, or you can round it off to 1.856. Next trial,
2.069.
2.069. Fourth trial,
2.142.
2.1. What is the bulk density for fourth trial? 2.142.
2.142.
Fifth trial, 2029 divided by 944.
2.1.
Bulk density is
2.149.
149. Last trial, bulk density is
2.042.
2.04. Okay, the final step of the table, you have to calculate dry density. Now dry density is given by bulk density divided by 1 plus W, and its unit will also be gram per cc. Now bulk density for the first trial is 1.697 divided by 1 plus W. Okay, water content is given in terms of percentage. Okay, water content is given in terms of percentage, but we have to keep it in terms of decimal. So 5% is nothing but 5 by 100. 5 by 100 is 0.0502. So please 5.02 divided by 100. So you have to keep water content in terms of decimal. 5.02% is 0.05. So if you don't understand this, how we have used this formula. Okay, dry density is equal to dry density is equal to bulk density divided by 1 plus W. So in the first case, bulk density is 1.697. So 1.697 divided by 1 plus water content. Water content is 5.02%. I have to write it in terms of decimal. That is 0.0502. So what is the dry density? Dry density for the first trial, 1.697 divided by 1 plus 0.0502.
1.615.
1.615. So similarly calculate the dry density for second trial, 1.856 divided by, okay, the water content is 8.81, so 1 plus 0.0881. Okay, what is the dry density for second trial?
1.706.
1.706.
Yes, sir.
Third trial,
1.8597.
1.8597. Fourth trial,
1.8947.
1.8947.
47.
Fifth trial,
1.878.
1.878. Last trial,
1.73.
1.73.
713, sir.
1.7113,
1.713.
13.
Okay. So we have to draw compaction curve. Compaction curve is drawn between dry density and water content. So I have water content for each trial and I have calculated dry density for each trial. Now I have to draw graph. Okay, I'll at least explain how to draw graph. If you have scale and pencil, you can draw it in your book itself if you don't have a graph sheet. So I have my values. I have to draw graph now. So this is my x-axis. And this is my y-axis. X-axis is dry density. Sorry, y-axis is dry density and x-axis is water content. So now how to take scale. X-axis is not a problem. Okay, the values range from 5 to 20. So there are 20 lines in my X division. So I can take 1 centimeter is equal to for x-axis in my graph sheet. I can take scale 1 centimeter is equal to 1%. If you have a scale, just draw a 20 centimeter line in your x-axis and that will be your x-axis. And you can mark at 1 centimeter all the values. Here I'll mark at 5 centimeters. So this is my 5%. This is my 10. 15, 20. Okay, so x-axis is water content. You can take 1 centimeter is equal to 1%. Oh, sorry, 1 centimeter is equal to 1% as scale. Next, for the y-axis, you don't have to start from 0. Okay, x-axis you started with 0. Y-axis you don't have to start with 0. See what is the least value. Least value is 1.615 and highest value is, this is the least value and this is my highest value, 1.89. So 61 to 89. Approximately these are 30 units. So I'll start from 1.6. Okay, and let's say I'll take 1 centimeter is equal to 0.2 gram per cc. That is for your next 1 centimeter mark, it will be 1.62, 1.64, 1.66. Or if you think this is a very big scale, you can take let us take 0.4. So the next division will be 1.64. So this will be 1.68, 1.72, 1.76, 1.8, 1.84, 1.88, 1.9. So this is 1.64, 1.68, 1.72, 1.76, 1.80, 1.84, 1.88, and finally 1.92. So draw the graph. And then mark the points. I'll just show you this. So this is the In this case, for 5%, this is 5.02. We can take approximately 5. So for 5, it is 1.615. So it is nearer to here, 1.61. Next, for 8.81, 8.81 comes somewhere here, and 1.70. 1.70 comes here. So we can mark a point here. Next, 11.25. So 11.25 is here, and 1.859, approximately 1.86. So 1.86 is here. So this is my point. Next, this is 1.89, that is approximately 1.9. This is 13. So 13 is here, 1.89 is here. Next, 14.4, 14.4 is here, and 1.87, so 1.88. I'll round it up to 1.88. Finally, 19.25, it is somewhere here, and 1.713. I'll round it off to 1.71. So 1.71 is here. So my final point is here. Now I'll draw a freehand smooth curve. And join the points. So this is my compaction curve, and the highest point, the density corresponding to highest point is my maximum dry density. And the water content corresponding to uh, the highest point is optimum moisture content. So this is my maximum dry density, and this is my optimum moisture content. So maximum dry density is around 1.95 gram per cc. Optimum moisture content is 13.0, 1.89 and 13.0. So maximum dry density is approximately 1.89. What I have drawn here is a very rough graph. OMC is equal to optimum moisture content is equal to 13.05 or 13%. So my answer, maximum dry density is 1.89 gram per cc. Optimum moisture content is 13%. Any doubts as to how to draw the compaction curve? The only point I want to stress is when you're taking scale for dry density, please see what is the highest value and what is the lowest value. Don't start the y-axis from 0, but if it is 1.61, start from 1.5 or 1.6 or 1.4, and depending on the highest value, choose your scale. 1 centimeter is equal to 0.4 or zero point 0.3 or whatever. If you have understood, please raise your hand. Very important problem in almost all the exams. This problem is asked for 10 or 12 marks. Okay, so we drew the compaction curve, and we found out what is the value of maximum dry density and optimum moisture content. So this is my answer. From the graph, optimum moisture content is 13.2%, and sorry, it is 13.02%, and maximum dry density is 1.895 gram per cc. Next part of the question, very simple. You are supposed to find voids ratio and degree of saturation for this condition. So we have this expression. Uh, Dry density is G into rho W divided by 1 plus C. Now because this is in terms of density, that is 1.895 gram per cc, density of water will be 1 gram per cc. If this was in terms of kilonewton per meter cube, this value would have been 9.81. So this is 1.895 gram per cc. This must be substituted in terms of gram per cc, 1 gram per cc. So if you substitute all the values and you simplify, you will get the value of E as 0.46. And again, we have this relation S into E is equal to W into G. So S will be equal to W into G divided by E. So value of S will be 79.48%. Simple calculation. Okay, so this is the first problem. Tomorrow I'll solve 2 or 3 problems based on same compaction curve. Please be ready with graph sheets. Okay, so we'll meet again tomorrow, uh, and we'll solve problems on same compaction test. Okay, so that's it for today's lesson. Thank you.